The last example of a collection class that we're going to look at is the dictionary. And dictionaries are used to associate a particular key with a given value. And you can think of them as lookup tables. Essentially, you use a key to look up a value. So if I have a dictionary object, then I essentially have a key that's associated with a value inside that dictionary. And some examples of that might be a product ID with a product name, or I could associate, say, an abbreviation for a state name with its full name. But really, I can associate any object with any other object. This is what hash tables are essentially used for. They're probably one of the most useful collection classes out of all of them. Keys have to be unique. You can't have duplicate keys, and dictionaries don't have any sense of order. So unlike other collection classes like stacks or queues or arrays, there's no sense of order here. You simply put in keys, associate them with values, and there's no notion of who's first or who's last. Probably the most common example of a dictionary is the hash table or associative array. You've probably heard it called many different names depending on what other programming language you may have come from. If you've never heard of it before, then I'll introduce it to you now. The hash table is an example of a dictionary. And the hash table class in C# is declared the same way you declare any other collection class. You simply have the hash table class. And in this case, I'm declaring a variable named myHT, which is of type hash table. And then you just use the new operator like you would any other class. So this will create a new hash table named myHT. And then we can start adding things to the hash table. And the way you do that, well, there's a couple ways to do it. But the first way to do it is just to use the add function. When you add something to a hash table, you give it the key that you want. So for example, I could give it a 3-letter airport code like SEA, and then I give it the value, which might be something like Seattle-Tacoma Airport. And then over in the hash table, I would have a little key named SEA, and it would be associated with a value. And I could do the same thing for, say, SFO, and that associates it with San Francisco Airport. I can also use bracket notation. For example, I can say myHT, and then in brackets, I can have the 3-letter code for IAD, which is Washington's Dulles Airport. And using the bracket notation, I would simply use the equals or assignment operator to say myHT sub IAD is Washington Dulles Airport. And that would also put something into the hash table. That's how you get data into the hash table. The way that you get data out of the hash table is to use the remove function. In this case, I would call myHT.remove, and then I give it the name of the key that I want to be removed. So if I wanted to remove San Francisco Airport, I would simply say remove SFO, and that would cause SFO to be removed from the hash table. Just like other collection classes, there's a couple of utility properties and so on. For example, I can see how many things there are in the hash table by using the by now ubiquitous count property. This will tell me, in this particular case, there's 2 things in the hash table. I can also see if hash tables contain certain values by using a test. I can, for example, declare a Boolean variable named B and call the contains key function on a given hash table. And I can pass in a key name, in this case SFO, which will return false now because it's gone. Or I can also use the contains value version as well. So I can say, hey, hash table, do you contain the value San Francisco Airport? In this case, it's now false, but if it was still there, it would be true. So let's just jump over to the code and make ourselves a hash table and exercise this. So here I am in the code. Once again, you'll notice I'm using the system.collections using statement up here. That includes the namespace for the collections class, which include things like dictionaries and hash tables and queues and stacks and all the examples we've been using so far. So jumping over to the snippets code, you can see I've scrolled down to the dictionary section, and I'm going to copy the setup code over here. And copy that, and we'll paste it into the main. You can see on line 13, I've created a new hash table, and then I've added some data to the hash table. I've added airport codes, SFO, SEA, and IAD, and I've set their associated values to the full names of their airports. And then we can test this out by saying, hey, let's do a console.writeLine to see the value for key whatever is this. And we're going to pass in the name of that key. And in this case, I'm going to look up the value by using the bracket notation. So you can see here on line 16, I use the bracket notation to set the value. I can also look up the value by using the bracket notation, but without an assignment operator. So I'm going to do a build. You can see the build succeeded, and we're going to run it. And you can see it worked fine. The value for key SEA is Seattle Tacoma Airport. That's great. Okay, let's continue on with the exercise. I'm going to copy this line here, which simply tells me how many items there are in the hash table. So I'll save that and run it. And as you'd expect, there are 3 items in the hash table. Okay, so far so good. Let's do our last exercise right here. Copy. And we'll paste this in. And in this case, we're going to exercise the remove functionality. But before I uncomment that remove line, let's just go ahead and write it out right now. You can see that the value for key SFO is San Francisco Airport. That's because SFO is still in the table. I haven't removed it yet. But if I uncomment this line right here, I'm going to remove the SFO key. And then the next line is the if statement on line 22 that says, hey, if my HT contains the key SFO, then write it out. Now that condition is going to be false because we've removed it. So let's run it again. And you can see that this time there was no write line for the SFO key because it's not there anymore. Hash tables are probably one of the most useful of the collection classes. And if you're coming from a language like JavaScript, you've probably used these a lot. In fact, they're used all over the world of programming. And in C# it's no different. You can use hash tables to associate keys with objects or any other kind of data that you can think of. And they're pretty useful. They're also pretty efficient. If you find yourself in need of having a lookup mechanism, a hash table usually fits the bill.